the previous video, we have already seen the statements of the Fourier transform's properties. Today, in this video, we are going to understand the proof of the properties. So, one by one, we will see all the properties and their proofs. So, the very first property is linearity property. The statement of linearity property was A f1t plus f b f2t has a Fourier transform A f1 omega plus B f2 omega. So to prove that, we know the formula for Fourier transform is f of omega is equals to integration over the limit minus infinity to infinity f of t e to the power minus j omega t dt. So instead of ft, we can keep this a f1t, and then in the second part we can keep b f2t. Now you know that a and b are arbitrary constant. So we can keep these arbitrary constant outside the integration. So a and b can be kept outside. The remaining part will be minus infinity to infinity f1t e to the power minus j omega t for first function and f2t for the second function. So if this is ft e to the power minus j omega t has a Fourier transform f omega, f1t will be having Fourier transform f1 omega and f2t will be having Fourier transform f2 omega. So the transform will be a f1 omega plus b f2 omega. This is the statement of the linearity property. So this is a very simple proof. You can easily prove it in exam. The second was scaling property. Scaling property states that f of at has a Fourier transform 1 by a f of omega by a. So to prove that, instead of ft, we keep f of at in this formula. Now let at is equals to x, so a dt will be dx and dt is equals to dx by a and t is equals to x by a. So by replacing all these terms, f of at will become f of x, e raised to the power minus j omega t will become x by a and dt will become dx, and 1 by a I can keep outside the integration, so it will be the modified statement of this. Then next step, 1 by a minus infinity to infinity f of x e raised to the power minus j. This a can be written as omega by a into x dx. So if it is f of t e to the power minus j omega t dt, it will be f of omega. But now our omega is replaced by omega by a, so our transform will also replace by omega by a. And obviously 1 by a is outside the integration, so it will be 1 by a f of omega by a, which is nothing but the Fourier transform of f of at. So this way we can prove linearity property as well as scaling property. Now the next property is time shifting property. So the next property is time shifting property. In time shifting property, the statement says that f of t minus t naught has a Fourier transform f of omega e raised to the power minus j omega t naught. So let us prove it. The formula for Fourier transform is the same. Instead of ft, now we will write f of t minus t naught e raised to the power minus j omega t dt. Now let us take t minus t naught is equals to x. So t will become x plus t naught and dt will become dx. So replace these things in this formula, it will become f of x e raised to the power minus j omega, t will become x plus t naught and dt will become dx. So we will separate these exponential term, it will become f of x e raised to the power minus j omega x dx, and the remaining part is e raised to the power minus j omega t naught. So this part is nothing but f of omega, so this is f of omega e raised to the power minus j omega t naught. Now same thing can be proved with plus sign. If this is plus, this will also be plus. If this is plus, this will be plus, this will be minus. The rest of the things remain same. It will be minus, then it will become plus, it will become plus. So f of omega e raised to the power plus j omega t naught. This is how you can prove the time shifting property with positive sign. So both are same. Okay. Now we will move to the frequency shifting property. Frequency shifting property statement says that f of t e raised to the power minus j omega naught t has a Fourier transform f of omega plus omega naught. So to prove that, instead of ft, we will write this whole thing under the integration. So minus infinity to infinity f of t e to the power minus j omega naught t, then the part of the formula e to the power minus j omega t dt. Now these exponential terms can be merged or combined. So it will become f of t e raised to the power minus j omega, omega plus omega naught t dt. So if this is ft e to the power minus j omega t dt, it will be f of omega. Now omega is replaced by omega plus omega naught. So the transform will also replace by omega plus omega naught. So it will be f of omega plus omega naught. Same thing can be proved with plus sign. It will be minus, it will be plus, it will be minus, and this will be minus. So same thing can be proved with the help of the reverse polarity. So this way we have proved till now 4 properties of Fourier transform. Now we will see the convolution property of Fourier transform. So now we will see the convolution property of the Fourier transform. We know the convolution of two functions f1t convolution f2t has a Fourier transform f1 omega into f2 omega. That means in frequency domain, the Fourier transform is simply multiplied. So the convolution mathematical statement is f1t convolution f2t states that integration over the limit minus infinity to infinity f1 tau f2t minus tau d tau. So now we have to calculate the Fourier transform of the convolution of two sequences in time domain. So our formula, instead of this ft, now we will replace this ft by convolution of these two sequences. So convolution of these two sequences this. So this whole thing will be kept instead of ft. So our formula minus infinity to infinity ft will be replaced by this whole thing, and then e to the power minus j omega t dt. So now this thing can be rewritten as minus infinity to infinity, again second integral minus infinity to infinity f2t minus tau e to the power minus j omega t dt f1 tau d tau. Now why I have written something like this? Because this thing, this part is nothing but time shifting property. So by time shifting property, this part will be what? f2 of omega, and it is shifted by tau, so it will be shifted in the exponential part. So e to the power minus j omega tau. So this whole thing can be replaced with this. So I have replaced it with f2 omega integration minus infinity to infinity f1 tau e to the power minus j omega tau d tau. Now f1 tau e to the power minus j omega tau d tau. This tau is replaced with t, so it will become this formula, which is nothing but f of omega. So if this is f1, then it will be f1 omega. So this is f1 omega into f2 omega. So this way convolution property can be proved. So these are the 5 properties of Fourier transform and their proofs. I hope you understand the proofs. They are very easy, and usually it will be asked in the exam to prove the properties.